Hello everyone, welcome back to the channel. I hope you're all doing great. If you're preparing for data analytics interviews, then this video is definitely going to help you. In this interview preparation series, my goal isn't to teach the entire subject of econometrics in depth because there are already many great platforms doing that. Instead, I'll focus on the concepts and questions that are commonly asked in interviews and explain them in a simple way so that you can answer confidently. In today's video, we'll build the foundation of regression analysis. We'll understand what ordinary least squares or OLS is, how it actually works behind the scenes, the difference between the sample regression line and the population regression line, and finally we'll understand linear regression and multiple linear regression with practical examples. So let's get started. The first concept we need to understand is ordinary least squares, commonly known as OLS. If you've ever studied regression, you've probably heard this term many times. But what exactly is it? Imagine you have a dataset with many observations plotted on a graph. These observations never lie perfectly on a straight line because real-world data always contains some variation. Our objective is to find one line that represents the relationship between these variables as accurately as possible. That line is called the best fit regression line, and the method used to find it is OLS. Now you might wonder how OLS decides which line is actually the best. The answer lies in something called residuals or prediction errors. Once a regression line is drawn, every actual data point will have some distance from that line. This difference between the actual value and the predicted value is called a residual. For example, if our model predicts that a student's marks will be 85 but the student actually scores 90, then the residual is 5. Similarly, if the model predicts 75 but the student scores 70, then the residual becomes -5. You may think we can simply add all these errors together, but that's not possible because positive and negative errors cancel each other. An error of +10 and an error of -10 would give us 0, making it look like the model is perfect when it actually isn't. To solve this problem, OLS squares every residual before adding them together. Squaring removes the negative signs and also gives more importance to larger mistakes. After adding all the squared residuals, we get something called the sum of squared residuals or SSR. The regression line that produces the smallest SSR is selected as the best fit line. That's why the method is called ordinary least squares. This is one of the reasons why OLS is used almost everywhere, whether it's predicting sales, estimating house prices, forecasting demand, studying customer behavior, analyzing financial markets, or building machine learning models. It's simple, efficient, and provides reliable estimates under standard regression assumptions. Now that we understand how OLS finds the best fit line, another important interview question is the difference between the sample regression line and the population regression line. Let's understand this with a simple example. Suppose you want to study the relationship between study hours and exam marks for every student in India. Ideally, we'd collect data from every single student, but that's practically impossible because it would require enormous time, money, and effort. Instead, we collect data from a smaller group of students called a sample. Using this sample, we estimate a regression line, and this estimated line is known as the sample regression line. The population regression line, on the other hand, represents the true relationship for the entire population. Since we rarely have data for every observation, this true line remains unknown. Our objective in econometrics is to use the sample regression line to estimate the population regression line as accurately as possible. A simple way to remember this for interviews is that the population regression line represents the truth, while the sample regression line is our best estimate of that truth. If the sample is good and representative, the estimated regression line will be very close to the actual population regression line. From here, the discussion naturally moves to linear regression itself. After all, we've been talking about a regression line for quite some time, but what exactly is that line, how is it formed, and where is it actually used? Let's understand that next. Now that we understand the difference between the sample regression line and the population regression line, let's understand what a linear regression line actually is. A linear regression line is simply a straight line that explains the relationship between two variables. One variable is called the independent variable, which is used to make predictions, and the other is the dependent variable, which is the outcome we want to predict. For example, suppose a company spends more money on advertising. Can we estimate how much its sales will increase? Or if a student studies for more hours, can we predict their expected marks? These are exactly the kinds of questions that linear regression helps us answer. You might notice that not every data point lies exactly on the regression line, and that's completely normal because real-world data is never perfect. There will always be some variation due to factors that we haven't included in our model. The vertical distance between an actual data point and the regression line is called the residual, or the error term. As we discussed earlier, the objective of OLS is to find the line that minimizes these residuals overall. The equation of a simple linear regression line may look a little intimidating at first, but the idea behind it is very simple. It helps us estimate the value of the dependent variable based on the value of the independent variable. You don't need to memorize the equation right now. What's more important for interviews is understanding the concept behind it. Linear regression has countless real-world applications. Companies use it to forecast sales based on advertising budgets. Real estate firms estimate house prices based on factors like size and location. Banks analyze customer income to estimate credit risk. HR teams study the relationship between work experience and salary. Even hospitals use regression models to predict patient recovery based on different health indicators. The common idea in all these examples is that we're trying to understand how one variable changes when another variable changes. Now, here's an important point. Linear regression works well when we have only one independent variable. But in reality, most problems are influenced by multiple factors, not just one. Let's take the example of house prices again. Do you think the price depends only on the size of the house? Of course not. It also depends on the location, the number of bedrooms, the age of the property, nearby schools, connectivity, parking availability, and many other factors. Similarly, a student's marks don't depend only on study hours. Attendance, previous academic performance, assignments, class participation, and many other factors also play a role. This is where multiple linear regression comes into the picture. Multiple linear regression is simply an extension of linear regression where we use two or more independent variables to predict a single dependent variable. Instead of relying on only one factor, the model considers all the important variables together, giving us a much more realistic and accurate prediction. For example, if a company wants to predict its future sales, it may consider advertising expenditure, product price, discounts, customer ratings, seasonality, and competitor pricing together instead of relying on just one variable. Since real-world business decisions are affected by many factors simultaneously, multiple linear regression is far more practical. One of the biggest advantages of multiple linear regression is that it also tells us the contribution of each independent variable, while keeping all the other variables constant. This helps businesses identify which factors are actually driving the results, and which ones have very little impact. That's why multiple linear regression is one of the most widely used techniques in data analytics, finance, economics, healthcare, marketing, and machine learning. Whenever multiple variables influence an outcome, this model becomes the preferred choice. So, if you're preparing for interviews, always remember this simple difference. Linear regression uses one independent variable to predict the dependent variable, whereas multiple linear regression uses two or more independent variables to make better and more accurate predictions. With that, we've covered all the important concepts planned for today's session. We started by understanding ordinary least squares and how it finds the best fit regression line by minimizing the sum of squared errors. Then we learned the difference between the sample regression line and the population regression line, understood what a linear regression line actually represents, and finally extended the same idea to multiple linear regression with practical examples. These concepts form the foundation of econometrics and are among the most frequently asked topics in data analytics interviews. Once you're comfortable with these basics, understanding advanced topics becomes much easier. In the upcoming videos, we'll continue this interview preparation series and cover concepts like regression assumptions, multicollinearity, heteroscedasticity, autocorrelation, dummy variables, and many other important interview topics with practical examples. If you found this video helpful, please support the channel by liking the video, sharing it with your friends, and subscribing if you haven't already. On this channel, you'll find interview-focused content on econometrics, statistics, Excel, SQL, Python, Power BI, Tableau, and data analytics, all explained in a simple and practical way. Thank you so much for watching, and I'll see you in the next video. Until then, keep learning, keep practicing, and all the very best for your interviews.